Any last chance at a business question? This is the last time I'm gonna see you guys this semester. Maybe ever, unless I see you next semester.
So for the workshop class,
Yes.
the final quiz that's due next week,
Yep.
that's for extra credit only, right?
I believe it is, yeah. Yeah.
So it won't hurt my grade if I don't do it.
You don't have to do it. And you have to get a 70%, I believe, in that class to get a pass. Anybody else? Yeah.
Week 10, we had like the Thanksgiving homework.
Mm-hmm.
And also gave us a quiz.
Oh, really?
Open.
Oh, okay.
We're not gonna get dinged for doing that later.
Not for doing it late. No, just make sure you do all of them at some point. Yeah, you have until next Saturday to get everything in. I'm not going to grade anything until then, or until Sunday, basically. But I will grade everything Sunday, Monday. So please, please, please turn it all in. And give me permission to when you turn in your presentations, you have to make sure you give my email address, share permissions in Google Drive, or I will not be able to see it. And I will not have time to chase you around, and you will get, it will hurt. So don't do that. Any other questions? What else do I want to say? I usually in the past have taken this last class to kind of weave everything together that we've talked about so far, but I've spent so much time doing that. I feel like our conversations this semester have really danced around all of that. I thought it would be more fun to just talk about Earth-destroying asteroids for the last day, so that's kind of what I prepared to talk about. But maybe, and as I tend to do, I'll probably run right up to the bell with that. So before we get to that, maybe, I'd love to hear just any thoughts from last time, thoughts about, the solar system in general, that this is kind of our last chance to really talk about these things as a group. So yeah, just I'd love to just hear from you guys about anything that's sticking out in your minds before we close this course down. Yeah. Oh, another business question. Yeah.
The video, is it like this time limit is 10 minutes, or you have to like up to 10? I didn't ask that.
I would say that you have to go. I would not do much less than 10 minutes because you probably won't. It's not much of a presentation otherwise. It's not deep enough. If you want to go over 10 minutes, it's not going to hurt me. If you go like 3 hours, I might just read the transcript. But you're welcome to do 3 hours if you want. I just, I might not watch it. Yeah.
I just wanted to, did everyone get a message here about that?
Yeah, I saw that. Seems to have not been a huge issue, though.
It's further south near Humboldt County.
Yeah. Yeah, it was off the ocean, and it doesn't seem to have damaged too much. So that's really nice. No big tsunami either, which is really nice, right? They did, yeah. Yeah, it's always in the back of my head when I'm out there on the coast.
I know, I'm always like...
You're like, it's gonna happen. Well, they happen like every 700 years or something, and we're kind of due for one. They're pretty regular, like, you know this about the Oregon coast, right? It's like, and yeah, every few hundred years, it's pretty regular. There's a big subduction tsunami. And I think the last one was recorded on the coast of Japan from here back in the 1700s. And so, yeah, I think it's creeping on time to have another one. It's certainly, I don't know if it's overdue, but it's going to happen. I think that's part of the reason why everything's so young looking on the coast, too. It's very, the trees aren't really old on the coast and stuff, right? And you see all these tree graveyards, actually, from some of the previous, there's some not quite fossilized, but ancient trees that are still, sticking out of the water and stuff. It's kind of crazy. Yeah.
I just wanted to point out something with this real quick. It was California's first 7.0 study started.
Really? Crazy. All right. Yeah, life goes on. What about the solar system? I mean, yeah, any thoughts from last week? I mean, the moons are a little tricky to talk about just because we know so little about them. Yeah.
So cut off in the made of asteroids and comets. I think
2 nights ago, I was getting up super late from work, I was walking back from my car at like 11 at night, and I just saw this ginormous comet, like softball size in the sky.
A meteor, yeah.
Yeah, and then another one, smaller one right after it. I was just wondering if there's a way
Wow.
to find out what that might have been. If that was a good thing.
Like, all right, so the thing is, most of those are really, really tiny.
Yeah.
Like most of the ones that you see in the sky are like grains of sand. They're really, really tiny. It's just that they're getting completely ionized and just absolutely busted up. So, and they're ionizing all the air in front of them, which is how you see. So yeah, there are like military databases that track these things, but they're not super easy to access. One of the gentlemen that I was going to talk about later, there's a guy who thinks he's been tracking these interstellar asteroids, right? And that's kind of debatable because it was generally assumed that nothing had ever come from outside our solar system into our solar system. Anyways, he thinks he's found one, so I'll talk about that a little bit. And how he went about finding it was through accessing these military databases and stuff like that. But it's people argue about it, and they're like, yeah, it's tricky. Yeah.
I guess I have some questions about, NASA recently released something about, for like a solar maximum or something, like, was that something we talked about earlier this year, or?
I mean, the solar stuff's definitely more. We talked a little bit about the sun cycles for about 5 seconds, but yeah, the sun obviously goes through this same pole reversal that we're going through, but on a much faster scale. Like, every 20 years it goes through this loop basically, and it's very predictable. And as it's going through that, the magnetic activity on the surface of the sun and the corresponding space weather, so the impact on our upper atmosphere and our weather is affected because it's either a lot of activity or not a lot of activity. And it's very regular. And there's also bigger cycles of solar weather and stuff. We're going to talk a ton about that. Is anybody actually going to take this class next semester? Nice. All right, we'll talk about it. Anybody on the fence about taking it? All right, think about it. Yeah, I mean, it's a very different set of topics when we start. The sun is sort of the Rosetta Stone of astrophysics, right? It's the thing we have the most data about. It's right next to us, and if we can understand it, then we can understand a lot of what's happening in the sky. But yeah, that's debatable of how much how much of the data we've made sense of in terms of these things and why these cycles happen and everything. So yeah. So if we're at a maximum, I think it'll be 10 more years that it tapers off, and then we'll be in a minimum, and then it'll come back on again, basically. Yeah, it's pretty predictable.
Last class we talked about how some of the moons of Jupiter were formed from smaller objects coming together, or it's theorized to be that way. How would they not? I just did the activity on the workshop that was asteroids they stay as smaller things, separate things, because they're influenced by the gravity of Jupiter. How would the moons have not just stayed asteroids? How would they have come together like that?
I mean, that's a great question. I think that's the main thing. I've spent many hours talking to the guy who made that video, and they don't have a solution for how you glue boulders together to make planets, basically, or how you glue pebbles together to make boulders either, right? These are really, it's kind of the crux intractable problem in all of these models that I can see. I mean, the idea is maybe if there's a ton of really thick gas that you can kind of immobilize these things, and by scraping out little voids in that gas, you kind of pack more stuff into those voids as a result of it. There's various ways to sort of squirm through it, but I don't find them personally very attractive as formation explanations. I think that the nucleation explanation makes a lot more sense to me, anyways. Especially, but this is guys gotta understand that the evolution of Neptunes into mini Neptunes into super Earths is that idea has only been entertained seriously in the last couple of years. It's so brand new. I wouldn't expect that to be, anywhere near a textbook for 20 years, something like that. It's just kind of how it goes. Um, so, yeah.
So, but in that video, were they, you know, obviously they were given like timescales for the formation of these moons, but is the way they kind of thought those moons formed very similar to how our solar system?
Yes, exactly. Yeah.
So it's like, it's the same, it's just the same process.
Mm-hmm.
Yeah.
Mm-hmm. Yeah, basically, pretty much. Yeah, I think that's a fair way of looking at it.
But I think it's about how our solar system has, I think, at least one of each type of planet, like the Earth line, building, ice and water.
Mm-hmm.
Are there any solar systems that we've observed that have the same like each one?
I think there's a couple. Yeah. I think 90% of them are homogeneous, though, if I recall correctly. There's a paper I'll go over. I usually do it next semester, but there's a paper that examines and divides it up into 4 different types. I think it's like homogeneous ones, completely mixed up ones, and then ones where the little guys are on the interior and the bigger ones are further out, because that's pretty common too. I mean, but the main kind is basically planets that are all the same. No, it could be like a sampling error too. It's hard to tell at this point. Like it might just be that the big planets are easiest to see. And so if you're looking from far away and you don't have a lot of information, maybe you're just like, they're all kind of the same because there's the big ones that you can see. I don't think you're going to be able to see an Earth-sized planet from across the, from 300 light years away. But yeah. Any final thoughts, guys? Last chance. Yeah. I mean, yeah, we've talked enough about it, but I think it's a really exciting moment, and I think of all the sciences, planetary science is, I think, the most rapidly changing and updating science that I can see. A lot of the other sciences seem very much stuck in their ways, and very little, very incremental progress is being made in a lot of things. But this seems to be a situation where we're really, really starting to rethink these enormous questions of like, what is, it's all happening very quietly. Like I said, these ideas won't often make themselves into the textbooks for many years, but there's some pretty cool things developing. And so, yeah, anyways. Yeah.
Anyone that is gonna be like extraordinary.
Mm.
What should be, I mean, can you make it seem like there's a lot of things that have to discovered yet, and think about, and things that we're like rolling with that we explored, but is there anything that you can like part of the work? I know that
It's a really good question. I mean, the first thing that comes to mind is the sun itself, but that's something we haven't talked a lot about. I think that the material basis of the sun is really poorly misunderstood, but that's something that we have to really unpack next semester. There's something just interesting about, like, I don't totally have the answer for this yet, but there's something very interesting about all of this, the way that science is done, which is, you ask for money as a researcher, as a scientist at like a major research institution, you ask for money for known problems, right? There's a known problem. And so you basically pick out a field that's pretty well developed, whatever it is, and there's some detail in that field that needs solved, and you can get money to work on it. It's very hard to get money to re-examine foundational elements of a paradigm in general. It's and so for me, it's like the biggest question really comes down to like how you encourage people to really take wide views and entertain lots of different ideas at once about something as foundational as, the history of the solar system or the history of the Earth. It's like, those aren't things you can really ask for money for, therefore you don't find a lot of professional people studying them. And so that's a really interesting question, like, is our institutional approach to science the best possible version of it? Is the way we're going about this the best possible way? Is there maybe in the future, I think a lot of people would say that the alternative is that you have people doing science outside of universities, essentially, because they're not necessarily tied to that same funding structure. That way they can get money from, wealthy billionaires or something that's not really tied to a legacy of this is how we think about the solar system, or this is how we think about anything, really. And so there's just some really complicated, I wouldn't say go so far as to say conflicts of interest, but there's really strong financial biases towards studying things that we already think we understand and continuing to solidify our understanding of them. So if I could wave my magic wand and change that, I would, but I don't know if that's the case. And then the sun, yeah. Once we look at the sun, and I wish this course was taught was organized in such a way that we could do the sun first, because it's very hard to make sense of everything else without understanding stars, because they're kind of like the central player in all of this. And I think it's hard to even understand planets without understanding stars, especially the formation ideas, right? And I've tried to kind of tiptoe around it because brown dwarfs being so similar, right? The stars and planets are ultimately not that different from each other, at least the big ones. And so, it's all part of one story at the end of the day. And we have a huge one sitting really close to us that we can study really well. And we can ask interesting questions that might help illuminate the rest of our evolutionary story that we've been trying to develop. But for whatever reason, we didn't have time to do this on this semester. So anyways, we'll do that. There's a fantastic YouTube channel one of my friends runs called Sky Scholar that has some really cutting edge stuff about the sun and the material basis of the sun. It's pretty intense in terms of like technical background, but there's also some good explainer videos on there too. So for you guys who won't be around next semester, for those couple of you that are sticking around, we will go deep on the sun, and then I think a lot of this other stuff will start to make more sense. All right. A little bit sad to leave all this behind, but so it goes. We didn't really make it to Pluto or anything like that. Sorry, guys. But let's talk about asteroids, because I don't even have my slides up for you guys. Give me 1 second. All right, so this is probably worth, so hard to find my mouse once I go over there. This is important for you guys. And I don't know if there's like a good mnemonic for you to remember this. These are some words that people confuse all the time, right? Meteor, meteorite, meteoroid, asteroid, and, well, I would say comet. But I hope that we can at least untangle all of those for you guys today. I'll just tell you the difference really quick, and then we can reinforce that as we go through this. So the meteor is actually just the light thing that you saw. So that's a meteor, like a meteor shower. It's like all these little streams of light. The meteorite is the thing that remains on the ground afterwards, if there's anything left, basically. Okay, meteorite. A meteoroid is basically a tiny asteroid. An asteroid is basically a tiny little planet. It could be like the size of a pebble or something, or it could be the size of a basketball. It could be the size of Ceres or Vesta, which are like a few hundred kilometers across. So all of these bodies, for the most part, are orbiting something like the sun, right? That's why we call them all like asteroid would be a minor planet technically because it's orbiting the sun. Sometimes we cross its path, right, and then we get smacked by it, like in the case of the dinosaurs or something like that. So I don't know if you guys have been paying attention to these orbital diagrams as I've been throwing them up there, but the orbits do cross each other periodically. Now, we're generally spared the problems that result from that because of those nice resonances that build up, right? Each of the planets is not only being tugged by the sun, but they're being tugged by each other. And they kind of pull each other out of the way just in time, for the most part. So that's why this concept of orbital resonance is so important. The music of the spheres, it really comes into play with that. With asteroids, not so much. So we actually are in the position of getting smacked by asteroids and meteoroids. But for the most part, every night we're getting smacked by some sort of meteoroids. Now, there could be tons of those little meteoroids in the wake of a comet as well, right? So there's very predictable ones that happen during in the aftermath of comets passing by, some very predictable meteor showers. But in general, those are the four things that we tend to get confused about. And honestly, it's technical delineation, but the only one that you'll probably really encounter is like meteor and meteorite, and then asteroid, I guess, to some extent. Comets, on the other hand, are these weird, they used to call them dirty snowballs. Now maybe they're called like snowy dirt balls, but they are essentially these very predictable, elliptically orbiting bodies, right? That either come from far, far away, they hang out far, far away on these really long elliptical orbits, or they make slightly closer ones, and we see them more often, but they're still going out into the icy regions. And they kind of, since they're all icy and snowy, as they get close to the sun, they tend to kind of cook off, and you get these beautiful tails as a result. So those are the main bodies that we're going to be talking about. When I start thinking about these things, the two pieces that are really interesting to me about this discussion are, one, that they completely threaten our existence, perhaps more than almost anything else I can think of. Yeah, it's like nuclear war would suck, but I think like some people would survive probably. What else? Like a completely disastrous pandemic would be awful, but I think some people would survive. There have definitely been impacts on the planet that have wiped out hundreds of species in the past, right? So like it's a real existential threat, and until very recently, we haven't had much of a beat on this, right? And so I think there's something really exciting to talk about, which is how do we keep track of these guys, right? And and it turns out we're actually doing a really good job of that. So as far as like success stories of science go, you know, I've probably in this course expressed some skepticism of like a lot of the typical success stories, like the ozone layer or something like that. But this one actually seems to be pretty radical. Like they're actually doing a really good job of tracking all of these near-Earth asteroids. And so I want to dwell on that for a minute. The other thing that's really exciting and interesting, but maybe not as, I mean, this has more, it's more open to ethical considerations, but asteroids are extremely mineral rich, and they contain a lot of metals and, what do you want to say, bling, basically. They have a lot of really expensive stuff in them. And so if we can get a hold of some asteroids, we can potentially maybe limit the amount of extraction that we have. Like, to look at it on the bright side of things, maybe we can limit the amount of extraction that we have to do here on Earth. I don't know how much you guys are aware of it, probably some more than others, but like the chips that go into these all these devices we have, our phones and everything, they require pretty bizarre atoms inside of them. Not a lot, but enough that it's expensive to dig them out of the earth. And not only is it expensive, it's usually done in third world countries by something approximating slaves. And so it's not a good situation. It's something we want to avoid. The question is, if we find a way to pull all of those atoms out of space, out of the asteroid belt or wherever, can we do it in a way that doesn't involve slavery? And anybody see The Expanse? I know I asked this once at some point. You guys got to watch The Expanse. It's such a good show, at least the first 2 seasons. The Expanse makes a good case for the fact that humans have a tendency to make slavery a thing wherever they go, whether it's wage slavery or whatever. And so asteroid mining becomes this kind of horrible situation where these marginalized people have to dig this stuff out of the asteroid belts and everything else. So I don't know. It's an interesting opportunity. So those 2 things I think are what I really want to focus on. Yeah. We'll get there in just a second, for sure. Yeah.
If we took asteroids to Earth,
Yep.
would that throw off the orbit of anything else around it?
I mean, the ones that people are talking about dragging around are pretty little, so I doubt it. But Carl Sagan you guys are too young for Carl Sagan, but he was an amazing dude. He made this interesting point that, like, hey, as soon as you have the ability to drag asteroids around and bring them back to Earth, bad guys have the ability to throw asteroids around. And asteroids are potentially way worse weapons than anything that we can make, even in the nuclear arena right now. So that's an interesting consideration because, okay, you've got the ability to drag asteroids out of the asteroid belt. It's like you could drop them on people too, right? So we're gonna take a look in a second. I got some videos, and maybe you guys saw these like when they happened, but asteroids that don't even hit the Earth but just skim the surface can like obliterate places, right? So, yeah, they're really big, and they essentially cause shock waves when they explode in the upper atmosphere. For all intents and purposes, I know it's hard for us to comprehend, but we're in a pretty thick medium right now. It's just like this air is actually rather thick. It's thick enough that if I were to compress it really fast, I could squish you guys, right? If I was like a bomb, basically, right? Like bombs, why do bombs kill people? It's like, yeah, they throw little fragments that cut you open, but the main thing that kills you is the air. As it compresses, it squishes your guts, and it blows up your insides, right? So the atmosphere itself compresses, and that's dangerous. You're basically just getting squished by the atmosphere. The same thing happens when these asteroids hit the air going at these supersonic speeds, right? They're moving at an incredible clip, and they compress that atmosphere in such a way that it squishes stuff and just obliterates a lot below it. And so I'll show you an example of this in a second. And there's been examples in the past too, particularly one event in Russia in like the early 1900s, where a little, what do they think, like a 20-meter wide boulder size meteor burnt up in the atmosphere and like leveled like 300 kilometers of forest. Just incredible. And now that didn't happen over a city, thank God, but that's certainly a possibility. And so a lot of effort, that ties into a lot of people really focusing on how do we track the things that are big enough to hurt us. And I'll show you where we're at with that project in a second. Just give you guys like a little bit more context on this. So most of the asteroids that we are aware of or have become aware of are the ones in this asteroid belt. And the asteroid belt's kind of interesting. Here's a good example of it too. There's like over 1 million of these that we've actually tracked inside of this asteroid belt, which is this region between the rocky planets and Jupiter. And the asteroid belt's, it's a little mysterious. One of the first things that most students would ask about the asteroid belt is like, is it the leftovers from like a planet that blew up or something like that? Which I think is a really interesting question. Now, the reason that most scientists will snap back with absolutely not is because there isn't a whole planet's worth of stuff there, for starters. So there's only something like 3% of our own moon's mass worth of junk in the asteroid belt. So despite there being millions of asteroids, they're all pretty teeny tiny and they're really spaced out. So it's not very dense. The second reason that people will give is that it's a very diverse crew of rocks. So and I'm going to talk about the composition of asteroids here in a second when we start talking about asteroid mining. But you'll see that there's carbonaceous ones, there's metallic-rich ones, there's silicate-rich ones. There's lots of different types. And so people say, well, it's too diverse, right? That argument, okay, both arguments, I think, are not sufficient to rule it out as a possibility for me. Because as we've looked at all of these planets, let's just take our own, the one that we know the most about. There's a great onion layer worth of stuff going on Earth, right? We see all sorts of really interesting stuff here. As for there not being enough stuff there, that's interesting too. I think it doesn't disqualify the fact that some sort of crazy collision may have happened at some point, though, because you can imagine something, getting completely kicked out of the solar system. So like, you're never going to basically find the murder weapon because it's like buried in the sea somewhere. You could also imagine like some layer of a planet literally getting knocked off, right? Some portion of it, and then that whatever that thing was, or probably two of them would be required in order to, or two or more, to crash into each other to make such a disaster. Maybe it's a moon somewhere, and we're just like, oh, it's a moon. That would make a lot of sense to me too. So I don't know. It's a big mystery. And people, there's one guy, I don't have his name off the top of my head, but I know there's a NASA dude from the 70s who made his whole career trying to argue that it was the results of a collision. Not a popular idea, but no catastrophism is popular today. And I think in some sense that's a little bit of wishful thinking and a little bit of a holdover from the anti-creationist arguments of the 1800s, where people really wanted to view the world as this gradual, slow, predictable, unfolding process. And I think we're still a little bit clinging to that. But I don't know. It's all really interesting. And then the other thing that just keeps coming to mind for me is like science as an institution, the one that we've inherited, the one that everyone's familiar with, it only will tell stories about things that it can see. It's not very comfortable with hypotheses, with things that you can't see being introduced in theories, right? And if we do introduce hypotheses, then they have to be these things we can test out and we can, actually make happen again, right? So it's useful, hypotheses become useful in a laboratory, but when it comes to the past, we're not very comfortable with them. So if I was to introduce a theory where I'm like, well, there was this hypothetical planet, it did this, it did that, people are just very uncomfortable with that. So it doesn't mean it didn't happen, it just means that's not really something that this institution of science is very comfortable dealing in. All right, so the asteroids are all very different. A lot of them are really tiny. There are a couple big ones, these guys in particular. The other weird thing about these two is that they're very rounded, but in particular, like Ceres is actually quite round. When we tried to explain why things are round in the cosmos, we generally say that it's a balance between hydrostatic equilibrium and gravitation. And that explanation doesn't work out for these guys. They're too little to have rounded themselves by gravity. So the only thing I can make sense of with them is that they're sanded down versions of something much larger. And so that's really interesting, even on its own face. How does that happen, right? Really weird. So in general, they're very diverse out there. And they seem to have been through a lot in the past. What do we want to say? Oh, last thing, I know I've said this before, but it's worth telling your friends. The average distance between asteroids in the asteroid belt is about 100,000 miles. So it's not the Star Wars, Chewbacca diving the asteroids situation. Okay, let's look at the composition of these things. So there's generally three types. There's the metallic type, the silicate type, and the carbonaceous type. What do we want to say about these guys? This all really points to the program of asteroid mining. So as of 2021, less than a single gram of asteroid material has ever been successfully returned to Earth from space. So that's not a lot. There is a project on the deck funded by an independent Japanese company which plans to bring back 60 grams. And that is going to cost $300 million. There's this follow-up mission, which is going to be $800 million. I don't know how much more they're going to bring back. Basically, we don't have the means to return a lot of this stuff to Earth as it stands right now. That doesn't stop people from trying. And I'll tell you why. Let me see if I wrote this down. There's recently, this one's popped into the news cycle lately. I guess I don't think that I actually wrote it down. There's a single asteroid that they identified in the asteroid belt, and I can't tell you the name of it, unfortunately, off the top of my head. But the value of rare metals in this thing approximates something like a quarter of the world's entire economic output in a year, which is like nuts, right? So, if you could somehow get this back to Earth and sell it, on the open market, you could do as much commerce as the entire world does selling every other good and service over the course of a year. So that's a lot, right? And this is, I think that thing is like 60 meters wide or something like that. So it's tricky. How much money is worth investing in that up front, and how much can actually feasibly be returned. And to some extent, I think that the biggest problem with getting this to be a usable program is that bringing stuff back from space is from orbit, even from low Earth orbit, right, is really, really tricky and dangerous and expensive, right? So getting through our atmosphere turns out to be, I've mentioned this before, it's the most expensive and difficult part of space development, right? Because you have to basically stick everything in a tube that pokes its way through the atmosphere. You essentially have to do the same thing in reverse coming back. And it's kind of a good thing because that's what protects us from getting completely annihilated by space junk all the time, right? So the atmosphere is both saving us, but it's also the most difficult impediment to industrializing any of these items. So the dream seems to be that you build facilities in space, you drag these asteroids back using different kind of mechanisms like sails or solar sails, things like this, and you actually harvest the materials you need from them there, and you build the stuff that you want to build there in space, maybe at the moon, perhaps, somewhere where you can do all of this work without having to negotiate the atmosphere of the Earth. So it's all very complicated, and all this infrastructure needs to be developed before that's even possible. What did I want to say about the, what you guys have some thoughts off the top of your head while I'm paused here for a second? Questions? Yeah? Oh, sorry, up front, then Nolan, yeah. Yes? Ah. Okay, yes, that's exactly where I wanted to go. So, you know what? I actually think there's going to be like a whole space, there's going to be space industrial tourism, there's going to be space cruise ships, basically. There's going to be space tourism on the moon. Like, just like, you know, do any of you guys have like boomer parents who like to go on like vacations on cruise boats around the world or something? We have some of those in our family. So I think the same way that people like to do that, to kind of experience these exotic places without actually having to move there and live there and do stuff, I think people will do the same thing with space. I think building the spacecraft for that kind of tourism is going to be cheaper to do in place in space, including all the technological, all the computers and all the stuff that goes into it. It'll be cheaper to do out there. In general, I think that space is, like it or not, some sort of a frontier that will be developed. And I don't know like how short-term or long-term or how successful that's going to be or how attractive it's going to be in terms of like, is anybody, David said he was going to move to Mars, but then he changed his mind. But like how many people are really going to want to do that on a permanent basis? I don't know. But I do think on a short-term basis, it's already very attractive. There's private companies already raising money and selling tickets to go to the moon, basically, right? For, can't remember, but millions and hundreds of millions of dollars, if not billions of dollars. So it's a very profitable industry if you can prop up some sort of space tourism, and all of the things that go into all the infrastructure that goes into that would be cheaper to make in space than to bring it into space. Yeah.
Due to other countries probably won't do the same thing with money, it's pretty hard to have the government funding a program to, they might, other countries might take out like a grant or something. I don't think this could ever be a possibility.
Yeah, I think that the political side of this is very tricky, actually. I think I was going to talk about that in a minute, but there's this but what I mean, this is as good a time as ever. So there's this space treaty that was signed in 1967, right? I think we talked about it with the Moon Treaty, which is related. But nobody signed this thing who needed to. And actually, let's see, the Obama administration basically said back in, what year was this, 2015, that a United States, I'm quoting the Obama administration, which was a bill they signed into action, a United States citizen engaged in commercial recovery of an asteroid resource or a space resource under this chapter shall be entitled to any asteroid resource or space resource obtained, including to possess, own, transport, use, and sell the asteroid resource or space resource obtained in accordance with applicable law, including the international obligations of the United States. And then the Trump administration in 2020 signed another bill actually, it was an executive order that said Americans should have the right to engage in commercial exploration, recovery, and use of resources in outer space. The U.S. does not view space as a global commons, and the U.S. opposes the Moon Agreement. So basically, all the countries who have the ability to go to space are like, have made no real agreement about how this is all going to go down. And we've seen how that's gone before, right? I think that the most close analog we have to this is the colonialization of the Western Hemisphere, essentially, after, the contact of the Americas was made by the Europeans, and all these colonial superpowers scrambling and fighting wars with each other and just complete and utter mayhem. I mean, that's what happens in the absence of some agreement as to how this will all be negotiated. So yeah, it's quite interesting. That's why when I think about all these things, I'm like, this is going to take a while, because even if technically and technologically, like, it's not that hard to pull off and the material gains are enormous, there's so much human politicking that just gums up the wheels with all of this, yeah. But my goodness, is it profitable? Here's another little factoid. A relatively small metallic asteroid with a diameter of about a kilometer contains more than, generally a metallic one, contains more than $20 trillion worth of industrial and precious metals. 20 trillion, for a relatively modest asteroid that you can mine, not a special one. I'm not talking about this like crazy one that they just found, which seems to be super dense in these metals. This is just an average metallic meteor. So it's like outer space is just jammed with busy space mines, right? It's like the gold rush, when everybody back in, what was it, the mid 1800s was like, there's gold in California. It's like, it's kind of the same situation with asteroids right now. And there are a lot of venture capital there's a lot of venture capital being devoted to that, people coming up with plans of how to get it, bring it back, use it in various ways, but nothing moving as of this exact moment. So any more thoughts on that? Concerns? Anybody want to jump into the asteroid mining business? Yeah. Somebody's going to do really rich, and a lot of people are going to go poor. Go bankrupt. That's kind of how the gold rush went too. It's funny. You guys know who got the richest during the gold rush, actually? That's right, exactly. So there might be some of that too. And I wonder to what extent, SpaceX or some ventures like that are going to be facilitating the transfer of supplies to space are going to be the people who are doing the serious business in all of this. It's hard to say, but that would definitely be the precedent for sure. Any more thoughts on asteroid mining? Yeah. Yeah. There's a guy who got in the middle of the class last year, some guy got his house hit by a meteor in Northern California, like right on the border. Anybody see this happen? Just like exploded his house. They're like, how that happened? Like last year, it happens. Yeah, it's actually like fairly common is the funny thing. Not necessarily exploding people's houses, but landing in their living rooms, landing in their cars, in their yards. Yeah, you can try to sell it. You can buy them on eBay if you want right now. Yeah, everything's for sale, folks, if you got enough money. I think a lot of those end up making their way to museums and stuff like that. But yeah, it's yours if you find it. Yeah, yeah, you can find them. People go out with metal detectors too, and they'll just find them too, because they tend to be metally often. So yeah. Any other thoughts? Watch out. Keep one eye sleep with one eye open. Yeah. He was actually taking it really well. I think insurance covered it. He was like, I'm going to get a new house. It was really...
They'd probably be like, that's a scam.
Yeah. I don't know. Everybody saw it happen, I guess. Like the asteroid everybody was like, wow, did you see that asteroid? And then, whatever, John's house like blew up. It's like, so it goes. There's been a couple of, so all these asteroids we've been talking about, they're even defined as being small, like tiny, tiny planets, right? Because they orbit the sun for the most part. And that was generally how people thought about asteroids forever. And even comets are thought to be orbiting the sun for the most part. There have been a few weird counterexamples to that in the last 10, 20 years that have forced people to think about that a little bit differently. So this is one such object, and I think there's been about 3 or 4 now that have been logged. Several of them were logged on those weird, like Defense Department satellite recording things we were talking about earlier, where they see these objects come in at trajectories that don't make sense if it's orbiting the sun, basically. This one in particular got a ton of press when it happened. It was called, it was named, I think, after a Hawaiian deity. It's called Oumuamua. A really weird trajectory. This thing came in and basically did a right angle at the sun, which essentially, like if you take an ellipse and you elongate it and you elongate it and you elongate it, at some point it opens up into a parabola. And that's what we're basically looking at here with Oumuamua. Now, people didn't really, first of all, people didn't initially want to believe that it came from outside of the solar system because that's, well, there's a number of reasons that's disturbing on basic science levels, but on other reasons too. This one was really weird too because it was kind of cigar-shaped. I don't know how well you guys can see this right now. It was also really weird because it sped up when it left. When it did that sort of right turn at the sun, it actually sped up in a way that didn't make any sense. And so some people were basically like, that's an alien spacecraft. And, you know, I think under normal circumstances, most people would just be like, yeah, like get those guys out of the room. The problem was that it did actually speed up for reasons that they couldn't account for. They tried to come up with this model of how these hydrogen gas pockets inside of it expanded when it got close to the sun, but they couldn't detect any gas actually shooting out of the thing as it passed by. And then, of course, the hyperbolic trajectory did indicate that it came from outside the solar system, and it's really freaking weird looking, you gotta admit. So, and then to make matters worse, the guy who was championing that idea was the longest standing chair of the Harvard Astrophysics Department. So he wasn't just some nut job, yeah. It was, yeah, this guy's gonna, oh, cool, nice. Yeah, he's actually a really fun guy to talk to. So we sat down with him a couple of times, and I love he has a blog too, like if you guys are into this kind of work. He does a really good job, and I think you'll agree, of just breaking down complex ideas into really, really simple arguments, right? He can take, especially like the math he uses, you know, physics often gets really kind of ugly math very quickly, and Avi's really good at avoiding that. So he's an interesting dude. I really enjoy talking to him now and then, and he's pissed everybody off with this idea. Now, I think that he has reached a new level of pissing people off because there was another one of these objects that that he picked off of one of these Defense Department, you know, scans of the sky, and he made a claim that he knew where it landed out in the Pacific Ocean somewhere, and that he was going to go get it. And you know that I remember talking to him before that went down, and being like, first of all, that's a really cool mission, but I'm really afraid that whatever you find, you're going to say that that was the asteroid. And so, of course, he goes out there, he hires this very expensive ship, brings like, I don't know, 30, 40 people from his lab out there. They dredge the bottom of the ocean, and they pull up a bunch of these metallic spheroid things. And lo and behold, Avi is like, this is the one. And like the entire rest of the scientific community is like, dude, like, how can you possibly say that like you've dredged the ocean and found this one rock that correlates with this one blip that was on this radar? It's a very interesting situation. Look, I want him to be right, and I want him to have found the interstellar asteroid, but I think that it's a difficult pill to swallow. So if you guys are interested, there's a ton written about that on both sides of the arguments. Maybe he did find it. I have no idea. I mean, the reason that I would love for him to have found it would be, I think that we could maybe answer this question about radiometric dating that we've been tiptoeing around this entire class, which is, why don't we find anything that's older than 4 billion years old in this solar system? Well, it would be really interesting if we dated something that we knew was from outside the solar system, and it too was only 4 billion years old. And then we kept finding things from outside the solar system. I think we would have to start really reconsidering what the heck it was about this 4 billion year old date limit that had nothing to do with the formation models. That would be really fascinating. But until we can conclusively say that we've picked up a rock that is from outside the solar system, we won't be able to answer those questions. So that's an interesting battle that's going on. Thoughts, anybody? Oumuamua. And Avi's got, he's really fun to listen to. He's got ideas about like what the aliens are doing, sending these things around. Like, it's a very well developed situation, right? He's got it all thought out. He's a real character. And he doesn't, the other funny thing, I was thinking about this, like, how does this guy just doing this without getting canceled? He doesn't do social media at all. He's like never been on Facebook or anything before. So he has no idea that like people hate him, I think. And, which is awesome in a way. I mean, it's kind of bad, it's kind of good, but I think he's just completely unaffected by the trash talking and stuff. It was kind of amazing. Okay, so let's take a look. Yes?
You said that, so there's this speed up after it goes past.
Yeah, yeah.
But I was thinking, wouldn't it be similar to like when we use the satellites to go around the planet orbits to speed up and change trajectory?
Those things speed up when they get close to the star and slow down when they move away. A natural gravitational effect. Yeah, quite the opposite. Yeah, this one's weird. Now you could have something, I think a comet could speed up because of this gaseous outburst, basically. Like as its side is facing the star, it will kind of off-gas, kind of like a rocket, basically. But they couldn't find any trace of that actually having happened with this guy, which was really weird. Yeah.
If we found rocks that were dated for 4 billion years and they were from outside the solar system, like what would that be caused by? Like what happened? What do you think happened 4 billion years ago that like?
I think that like I would move, look, if we kept, let's say we collected 1,000 rocks from outside the solar system and we never ever found one that was older than 4 billion years old. But nobody alive right now thinks that there aren't that in other words, that the universe has only been around for 4 billion years. So then we'd have to really start thinking about what processes are limiting our ability to judge the age of these rocks. So it might be that on average, no object in existence can go much more than a few billion years before it gets exposed to something that radically resurfaces it. That seems like a reasonable starting point for me, if that were the case, and we could not find that. Because there should be, look, otherwise we should be finding interstellar objects that are of all sorts of ages going back to the earliest parts of the galaxy, at least the first generation of stars and stuff like that, I would think. At least, 6, 7 billion year old ones, stuff like that. That'd be really interesting too if we do find those. But what's really weird to me is that, so you gotta also think, yeah, we've seen 3 interstellar impacts on Earth in the last 10, 15 years. That means the Earth is probably covered in interstellar junk, right? Because if we just extend 10 or 3, just do the math, like going back in time, this place is probably littered with stuff from that. And if that's the case, isn't that weird that we haven't detected anything really, really old here? Like, that's pretty bizarre. So my sense is just that we're a little too comfy with the absolute dates that we glue on these things. I think wouldn't be the first time it's happened that we're looking at the limitations of our measurement system rather than the actual final story on the dates of these objects. So I don't know, it'd be really interesting. But yeah, if we start finding like 20 billion year old, or I guess that's older than the universe according to cosmologists, if we start finding really, really old stuff, then maybe I would trust the dating methods a little bit more. That would be really interesting. All right, so I want to talk a little bit in the back half here about the threats of these things, right? Should we be worried? The answer actually, I think, is that we're doing a great job of keeping track of these things, but that's a really good thing that we're keeping track of them, because these things, this is just what, over 10-ish years, this little map that you see here. And just to give you guys like some sense of, like, these are just impacts that have happened, right? The ones that are kind of large, on the large size, not the largest, but the second largest, are about like 2 Hiroshima-sized bombs worth of energy that's detonating, right? So it's quite a few of those in that 10-year interval, right? Now the good news is humans actually inhabit a remarkably tiny piece of the Earth, which might be surprising. But if you really think about it, most of us live in cities, right? And most of those cities are kind of crammed together. And so there's huge portions of the Earth, most of it ocean, but also just huge swaths. You know, you probably notice this if you get on an airplane ever, right? You just see like most of America is just empty, right? It's kind of crazy. So just in an odds game sort of way of looking at this, is not a problem for the most part, that there's these huge Hiroshima-sized eruptions going on in the sky kind of all the time. They're mostly places where it doesn't matter. You know, the idea that this is even a serious problem wasn't entertained until really, really recently. This is probably hard for you guys to understand, but like this idea that an asteroid killed the dinosaurs, that was not the most popular idea when I was a kid, or even when I was in college, right? People didn't want to believe that such a thing could happen, actually. And it wasn't until somebody developed this really and thoroughly defended the theory using basically little evidence of melted rocks, these little techites, I think they call them, all around the area in rings around the Yucatan Peninsula, where they think that the Chicxulub impact happened, and dated that all according to when this mass extinction happened and all of this, that people finally, like in the 2010s, were as a whole, I think the scientific community finally was like, okay, fine. A meteor killed the dinosaurs. Another thing happened in the late 90s that was really shocking to people was that a comet called Shoemaker-Levy smashed into Jupiter. And I think I got a picture of that one. Do I? No. No, you can't see it on this, I'm sorry. But basically we saw a comet, we saw this kind of happen in real time. There's some beautiful movies if you want to check them out on YouTube, of this comet fragmenting, and it's just these enormous impacts, all of them the size of multiple nuclear bombs, right? And people just, I think the combination of these tides shifting really forced people to think about, you know, what would this look like if it happened to us in our lifetime? There's been a resurrection of an idea in the fringe archaeology community that there's this very bizarre climactic period right after the last glaciation called the Younger Dryas. Do you guys know about this? So there's this weird moment where the climate starts to warm up again, and then all of a sudden it just dips and gets really cold for a second. And so there's been this fringe archaeological community that has tried to make the case that there was some sort of an asteroid impact or a bolide airburst, which we'll talk about in a second, which is basically the asteroid skimming off the surface of the Earth. That caused widespread devastation and, you know, launched all this junk into the atmosphere and basically caused a mini ice age. So these are really new ideas. They're hard to stomach. People don't want to think that it's as sketchy of a situation as it is. But, you know, you don't have to take my word for it. Let me play you guys a movie really quick. So this is from the Russian city of Chelyabinsk. This happened in 2013. This might be loud, forgive me if it is. Let me see if I can get it to play. It's so hard to see the mouse, my God. This one was about the size of a single Hiroshima bomb.
Нихуя себе, это что такое? О, нихуя метеорит, блядь. Ебанулся. Нихуя себе.
All right, one more. Wait for a good one. Anyways, you guys get the picture. We could watch these all day. If I could ever find my mouse, my cursor again. Okay, so that thing was about 20 meters in diameter. Okay? There was one. Okay, so luckily this thing detonated in such a way that it blew up kind of really high up in the sky. It actually blew up quite a ways away from the actual town center. Although just from like window explosions, I think something like 1,500 people ended up in the hospital that night. So, pretty crazy for having hit near a city that was relatively small compared to, some of the cities that we can imagine. Now, there was a much more devastating version of this in recent history. So in 1908, a 60-meter wide bolide, that means like something that blows up in the air up there, was detonated over the Russian town, very rural area of Tunguska, around the Tunguska River. I don't even know if there's a town there. There's a river. Is there a town there? I don't know. It's in Siberia somewhere. Nobody was killed, completely unpopulated. The blast was actually, like the devastation, the forest that was leveled was actually the size of a major city though. So it's a little bit of you can see the kind of gamble that's going on here, right? These things happen. They happen pretty regularly. It's just that we're not where they happen to happen at for the most part when they're bad. So really recently, in the last really the last decade or two, NASA and various aerospace defense industries and so forth have really put their minds to detecting, tracking all of the near-Earth asteroids that are in any kind of orbital collision course with us. And it's been actually like pretty remarkable how good of a job they've done so far. So very quickly, let's see, I think by around 2010, so they started this project, I think in the late 90s, 1998, they basically set up this project to catalog all of these. And their goal was they wanted to track all of the objects that were about a kilometer or larger. Now, why a kilometer or larger? Yeah.
If they're already smaller, they'll just run up in the atmosphere. They don't really.
Well, the ones that we just saw that like leveled Tunguska were only 20 and 60 meters wide. So it's not that they wouldn't be a problem if they're smaller than a kilometer. It's that they won't be an existential problem. There will still be some people left. Once you go above a kilometer, you're talking about liquefying the surface of the Earth, essentially. If you get a direct impact with something, like the Chicxulub meteor, I think was thought to be, oh God, I shouldn't just throw this number out, but I want to say it was on the order of 100 kilometers. Chicxulub meteor size, 10 kilometers, sorry. Okay, so the one that took out the dinosaurs and pretty much everything else that was around was only 10 kilometers in size. So NASA's first goal was like, hey, look, we gotta track all the ones that are going to end humans, and then we'll deal with the ones that are going to end cities after that. Now, they actually pulled that off. They'd done 90% of the ones that were a kilometer wide by 2008. And I haven't read the studies myself, but I was just like pestering ChatGPT about where they were at with this right before class. And it seems like they've done 99% of the ones that are in the kilometer range at this point, and they're starting to move into ones that are all larger than 150 meters in size. That is the next group, and I think that they've done all but about 20% of those at this point. Now, a city getting hit with a 100-meter boulder would be lights out for a city still. So there's a lot of work to be done, but the fact that we've even done as much as we have in 20 years is kind of incredible. I think I feel like that's quite reassuring, and I'm glad that people recognize that it's an actual legitimate problem at this point. Now, what do we do if we do, right, all they're doing is detecting them. What happens if we do detect a 10-kilometer boulder on a collision course with the Earth? Blowing it up before it gets here turns out to be a scarier proposition than it seems like on its face, because you run the risk of essentially making a shotgun blast out of a single football that you used to have to deal with. So you're on the right track. Yeah, we have to mitigate it somehow. There's actually been, and so that's the other part of this project, right? And actually, if you pay attention to the headlines, this is something, both these projects are getting a lot of funding and attention. And I think that, you have a question? Oh, okay. So what to do about it once we find it and finding these things. We do definitely want to get it out of the way. So there's a number of ways to do that. It turns out, and there's been a couple of prototypical missions to solve this problem. One is the recognition that you don't actually need to destroy it. You just need to nudge it off course a little bit. So you can actually use a tiny little bomb on the thing, potentially, and nudge it off course. Now, even tiny bombs freak out the engineers, though, because they think, oh, well, what if we blow it into two pieces, and now we have two problems instead of one? So those don't tend to be super popular ideas. But there's really, really non-invasive ways of dealing with this. One is that you basically just send a little orbiter around the thing. So actually, by adding a little moonlet to the asteroid that's bound to it and affecting it gravitationally, you can kind of tug the thing off axis. And there's variations on that. You can literally just crash something into it. So this was actually, there was this 2005 Deep Impact mission where they did this. They actually filmed it. They flew two spacecraft. One crashed into the thing and one flew behind, so it could make the sort of selfie stick version of this. And they crashed into this 8x5 kilometer comet called Temple 1, and they knocked it out of its orbit a little bit. It was never on a collision course, but it was the sort of proof of principle of could you redirect these things? And the answer is yeah, pretty easily, actually. So that's kind of interesting. Now, the solutions also get extremely exotic, like this crazy contraption, the Hypervelocity Asteroid Intercept Vehicle. This has a little tiny bomb on the front of it, which I guess opens up a hole in the asteroid, and then you put this bigger bomb in the back of it that, now that it has a hole in it, it won't explode the asteroid and it just pushes it off course. I don't know. People have other ideas like shooting basically what amount to laser beams at it to push it off of course. What else do we got? Solar sails that you basically put in orbit around it. They kind of cause the thing to erupt volatiles on its surface and push it off course. This idea of just kind of slingshotting something at it. This is called a mass driver. It's basically a giant catapult. So you throw something at it basically and knock it off of its course. Somebody proposed painting the thing white on one side so that the sun actually deflects the thing off of course. I mean, there's a million of these proposals in place. The only one that's been tested is this Deep Impact mission, to my knowledge, but it does seem to be doable. Now, all of this does require that you have a good space launch infrastructure in place, right? You need to have a space program that's capable of getting something into orbit and get it to the right place quickly. And so perhaps that's the best argument ever for why we should be putting any attention into giving money to the space industry in general. All right, so those are the two. I think those are the two most interesting things about asteroids, as far as I can tell. Getting rich off of them and learning how to not go extinct by them. What do you guys think? Does anybody have? And we got 9 minutes left here. Do you guys have any thoughts, questions, concerns, interest in the future of all of this? Any thoughts? You guys feel safe? Safe at night? Yeah.
Is there something like the satellites, that help redirect asteroids or, well, what about this? Like, what if there were like giant asteroids out there, kind of blow them up already?
Like get out in front of it, just seek them out and destroy them. I think that's kind of what they're trying to do with this near-Earth asteroid tracking mission, is kind of get out in front of it. Yeah, so far they haven't found. I mean, it's weird though, because they're like, look, they have to find all of the big ones first. They seem to have done a good job, but even the small ones can be quite dangerous too, right? I think we've just really lucked out up to this point. We haven't had huge industrial scale cities for most of human history. I don't know. I mean, there is evidence that it has impacted cities in the past, but people argue about deep history. There's one part in particular. There's a settlement in the Near East. So, God, I don't know where it is. It might be in Israel, a really old city that they think that some group has argued was destroyed by an airburst at some point in time. They tried to connect it to the mythical story of Sodom and Gomorrah, which was kind of interesting. Everybody hated them, but it was an interesting story. Yeah. Near Earth means that that's a good question. Like, how close does it have to pass to Earth to be dangerous? I think they're looking at ones that will intercept our orbit in general. I don't know how close. That's a great question. I'll see if I can figure that out. Other thoughts? Slow it down and capture it. Yeah, I don't know. That's a good question. Okay, I just looked this up. Looks like anything within basically 0.05 AUs, so 5% of the distance between us and the sun, is something that they're tracking and trying. So they're looking at that band that's going to be within that haze. I mean, I think that slowing something down and putting it in orbit, like the technology to do that, and this is what Carl Sagan was going on when he was like, hey, look, if you guys figure out how to move asteroids around, you have a new problem on your hand, because that's going to be really useful as a tool of intimidation for somebody. And if that's the problem with like moving all of our, look, the problem with expansion, right? And I think this is what that show, The Expanse, deals with really well. Like, is that if we haven't solved the problems that we have on Earth and we start just expanding them into outer space, then it's just going to multiply our problems, right? Like, we don't know how to get along with each other here. We're going to still be dealing with all that stuff, and it's going to be 10 times worse because we'll have more power and more space to pull it off in. So it's unfortunate. What else? He was admonishing us, yes.
I think it's kind of funny because we were the one who put our coordinates up on.
I know. Yeah, I don't know about that. Give the aliens a map, right? Hopefully they're nice.
I was about the interstellar object.
Oh yeah, they're coming by. They're like, just scoping it out. Scoping it out. Maybe. It is pretty weird. Yeah, it is pretty weird that we haven't seen any aliens. But maybe we have. I don't know. Some people swear by it. Any final thoughts, guys? It's been fun going on this journey with you guys. I appreciate it's pretty much most of you guys who are here today have been here every single class for the most part, give or take a couple. And I really appreciate that. It's been nice to have this be a more conversational class, not just sitting up here yammering. Although there's been plenty of that too. You got a thought? Yeah. Gold, yeah. Oh yeah. and things much more valuable than gold. Gold's pretty, like platinum and these rare earths that you don't even hear about, like stuff that get, let's rare earths, weird stuff, cerium, yttrium, scandium, samarium, like just promethium, these really weird elements that occupy like the kind of ghost land of the periodic table. Sorry, there's a periodic table behind here. All these things that are out of reach on the periodic table that are really useful electronically for the most part, technologically, but there aren't a lot of them on Earth. So all that stuff, it's definitely more valuable than gold for sure, because it's rarer. Yeah. So, yeah, guys, good luck with your finals. It's been really fun to hang out this semester. And good luck in life. Good luck in general. See you guys.